Today we're going to take a look at the second part of Lesson 9.1, Correlation, and our Chapter 9, Packet, Correlation, and Regression. So today we're going to talk about graphing a scatter plot. So an economist wants to determine whether there is a linear relationship between a country's gross domestic product and the carbon dioxide emissions. The data are shown in the table. Display the data in a scatter plot and describe the graph using ducks. So we have our ordered pairs over here on the right, and we have our steps for how to graph it in your calculator. You hit Stat Edit. You're going to put all of the x values in L1, all the y values in L2. You're going to hit Y equals and make sure that plot 1 is selected. Then click the zoom button and choose 9, zoom stat. And that is going to present you with your scatter plot. So pause the video here and try following those steps, and then come back to see what your scatter plot should look like. So your scatter plot should look something like this, close to that at least. I just sketched this out. So if we describe it using ducks, it is going in a positive direction. Unusual or outliers, you could maybe say it has some gaps, but not really distinctive ones. It's definitely linear, trying to be. This is moderate. You could say weak, definitely not strong though, because we have kind of these pieces over here going out and doing crazy things. So I'd say moderate's a good one for that. So as the gross domestic product increases, so as we move higher up on the gross domestic product, the carbon emissions tend to increase as well. That's how we get that positive. Okay, and we have example 3 below here. With Old Faithful, located in Yellowstone National Park, is the world's most famous geyser. The duration in minutes of several of Old Faithful's eruptions and the time in minutes until the next eruption are shown in the table. Display the data in a scatter plot and describe using ducks. So in that example 3, follow those same calculator steps that we did here for the gross domestic product example. Pause the video and come back for the answers. Okay, hopefully you got a chance to try that scatter plot. Again, you follow those same steps of stat, edit, x in L1, y in L2. Make sure plot 1 is selected, zoom 9. And this should be kind of what your scatter plot looks like. So again, our direction, we're moving in that positive. This one kind of has a bit of a more distinctive gap there, so we could put gap in our unusual or outliers. And then C, its correlation would be linear. It's moving in a linear fashion. And again, our strength, I'd call this around moderate. Okay, our correlation coefficient. Correlation coefficient is a measure of the strength and direction of a linear relationship between two variables. The symbol R represents the sample correlation coefficient. Correlation coefficient is non-resistant. So what that means is that if you have a scatter plot and you get its correlation coefficient, if you add more points to that scatter plot that are in the pattern that it's going to strengthen that R value, make it larger. But if you add in points that are not part of the pattern, so if you add in some outliers, it's going to weaken that correlation coefficient. The range of the correlation coefficient goes from -1 to +1. So let's see what that looks like on our scale here. When you are going from -1 to -0.8, that's strong, negatively strong. And between -8 and -0.8 and -0.5, that's going to be your moderate, negatively moderate. Anything between -0.5 and +0.5, including 0, is going to be weak. These are where you're going to see a lot of your no correlations. From 0.5 to 0.8, have that positive, moderate, and from 0.8 to 1, you have that strong positive. So here's some examples of strongly negative, strongly positive, weak. Okay, down here at the end of this page, we have some examples of some graphs, and you kind of want to try and match their R value and what words you've used to describe them. So this first one, we can see that it's negative. So we know we need our R value to be negative. So we know it's going to be this one. Also, those are pretty closely together. So that -0.9 would put it in the strong. So that's a good description of it. So this would be strong negative correlation. Okay, so go ahead and try these other three. Pause the video and come back for the answers. Okay, hopefully you got a chance to try those. Here are your answers, and pause if you need to take a look at them. So to find our correlation coefficient, we are able to use our calculator. So we're going to look at that GDP and carbon dioxide example again. So we have our ordered pairs, and it tells us in our calculator how we can find that correlation coefficient. You want to make sure that your calculator is in stat diagnostic mode. So hit the mode button on your calculator, scroll down until you find stat diagnostics, and make sure that it's on. You kind of always want to do this while you're working with our scatter plots, otherwise it's not going to give you all of your information. Then you're going to hit stat, edit again, put in your x values and your y values. Then you're going to hit stat, calc, that should say calc, for linear regression. Your x list will be L1, your y list will be L2. You want to make sure your frequency list is empty. So hit calculate, and that's going to tell you your R value. So go ahead and pause this video for a minute, put those into your calculator, and find the R value. Okay, hopefully you got a chance to try those. Your R value should be R equals 0.882. We don't want to cut it off with too few decimal places. So 3 decimal places is a good place to go for our R values. So that would give us a strong positive correlation between GDP and CO2 emissions. So let's try example 6 as well. Follow those same steps using our Old Faithful data. Pause the video and come back once you have completed that. Okay, here's your answer for the Old Faithful data. Should give you an R value of 0.940. This gives you a strong positive correlation between duration and time. The last thing that we're going to look at in this lesson is correlation and causation. So the fact that two variables are strongly correlated does not itself imply a cause and effect relationship between variables. You might have heard the term correlation does not mean causation. That's what this is getting at. If there is a significant correlation between two variables, you should consider the following possibilities. 1. There is a direct cause and effect between the relationships. Does X cause Y? Is there a reverse cause and effect relationship between the two variables? Does Y cause X? Is it possible that the relationships between the variables can be caused by a third variable or by a combination of several other variables? And is it possible that the relationships between the two variables may be a coincidence? So if we look at the bottom here, this shows two different graphs that kind of follow along each other. They'd have a pretty good correlation. It says here an R value of 0.66, so that's moderate. It is the number of people who drowned by falling in a pool, and films Nicolas Cage appeared in between 1999 and 2009. So, do people drowning in pools cause Nicolas Cage to appear in films? Does Nicolas Cage appearing in films cause people to drown in pools? Or is there a third party that's causing this correlation? Or is it just a coincidence? Here, most likely, it's just a coincidence that these things have a moderate correlation. So, this kind of just showing you factually that correlation does not mean causation. Just because two things are correlated does not mean that they caused each other.